so that others can get us on the way. So it is important that electricians are not just able to construct, they should also be able to recognize faults and take action to help prevent them, as much as such as using correct means to test, inspect materials is vital. So now not all faults will be easily visible. Not all faults are easily visible, so some will be concealed and only take effect over a long period of time. So regularly inspection, testing, and maintenance will limit such faults. So normally after an installation has taken place, there are faults that are detected, or there are faults that will not be detected immediately. So inspection is done so as to curb these problems. So on completion of work, we will need to have the work commissioned and certified. This is to make sure that it matches the specifications and meets all requirements of safety. In many cases, it will not be the one carrying out these tasks. So there are some of the requirements. All the things that needs to be done. So on completion of this outcome, the candidate will be able to, number one, state the purpose of inspection and commissioning and factors, identify the purpose of and conditions of periodic inspection, list the relevant sources of information to facilitate testing and inspection, also list items associated with visual inspection prior to commissioning and identifying the instruments. The person will also be able to describe how to carry out the common tests, explain the need to comply with the test values, and describe the certificate process, describe the requirements of testing and procedures for dealing with documentation and clients. So those are some of the requirements. So we are going, I'll take you through the procedure of testing, what is needed during this testing, and the whole process of testing. So the purpose of inspection and commissioning. Once an installation has been done, we need to inspect. Why do we need to inspect? So another vital thing now, on completion of any installation, an inspection has to be done. So initial verification procedure, that is in order to make sure that this work is carried out satisfactorily. The inspection and test procedure must be carefully planned and carried out, and the results correctly documented. So we inspect and commission materials after the completion of works for three reasons. That is, number one, to ensure compliance. That is the BS standard. We are saying the British standards. Remember, our country normally uses the British standard, which is the BS standard 7671. The compliance with the project specification, that is commissioning, that is it is safe to use, and that is the compliance standard is, it is part 6 states that every electrical installation shall either during construction, on completion, or both be inspected and tested to verify so far as reasonably practicable that the requirements of the regulations have been met. So in carrying out such inspection, the test procedures, precautions must be taken. So these are the procedures that has to be taken. So the BS standard requires that the following information to be provided on the person carrying out the inspection and test of an installation. So number one is the maximum demand of the installation expressed in the amperes per phase. And we'll also look at the steps of testing. What are these instruments that we use to test? When we are testing now, specifically now, we make sure that the amperes per phase are in line, the number and the type of live conductors are at the point of supply, the type of earthing arrangements also needed there. We also talk about the type of composition of the circuit, that is including the point of utilization, the number of size of conductor, and the types of the cable installed. Those are the things that are being inspected. The location and description of the protective devices, like now the fuse, the circuit breakers, it has to be located. And then the details of the method selected to prevent danger from shock in an event of the earth fault. Now, it is important to remember that periodic inspection and testing must be carried out on installation to ensure that the installation has not deteriorated. And then the next thing is compliance with the project specification. It has also to be done in that once the installation is complete, we need to test it against the original specification for the work. This is in order to check that the finished installation matches the requirements that is laid out by the consumer and it's fit for use by the environment. So the following tasks have to be carried out to ensure that there is compliance. That is pre-commissioning, which involves the full inspection of the installation. It involves the full inspection of the installation and carrying out all tests required before the installation is energized. That is, it is also called the continuity, all polarity, and insulation resistant test. We are going to look at these tests, this type of test, and how they take place. Another one is commissioning, which include all tests which require power to be available, e.g., the measurement of the earth fault impedance, the earth loop impedance, and then another one is commissioning itself. Now, commissioning itself includes all tests which require power to be available, e.g., the measurement of the earth fault, loop impedance, and the functional test of the residual devices. The RCDs, we say that the RCDs, these are protective devices that are normally used for power that is temporarily installed. For example, power that is installed on areas, on working areas that are very risky, that is temporary, like a site, installation site, or a construction site, or maybe somebody working outside the building, maybe a grass cutter or something that they're normally protected. Those devices or appliances are normally protected using the RCDs. The RCDs are also called the residual current devices. So as commission involves the initial energizing of an installation, has to be carried out in a controlled manner with the knowledge of everyone involved. So this means that all other persons working on site at the time of energizing must be informed that power will be applied to the installation so that all precautions can be taken to prevent the danger. Now, safe to use. The final act of the commissioning process is to ensure the safe and correct operation of all circuits and equipment which have been installed and that the consumer's requirements and have been met. So this will also confirm that the installation works and more importantly will work under fault conditions. So after all, it is under fault conditions and leaves the property will be at risk. So we will go ahead and go to now. When using the test instrument, the following points will help us to achieve the safe working environment. We have to make sure that even when we are working, the environment has to be safe. That is, the person carrying out the test must have a thorough understanding of the equipment. And that is why we go through the training so that we can be able to understand what is needed. You can be able to understand what is needed or the requirement when doing the inspection. So the person carrying out the test must ensure that all safety procedures are being followed, e.g., erection of warning notices, barriers where appropriate. So the person carrying out also, the person carrying out the test should ensure that all the instruments being used conform to the appropriate standards. And the standard here now is the BSEN 6101 or older instruments manufactured to BS 5458. So when we will be talking about the IEE regulations, we will be able to look at these standards. The IEE regulations, that is the regulations for working out, or the regulations that enable that are normally set out for the installation regulations. Another one, we have to make sure that the person carrying out the test should check that the test leads, including probes and clips, are in good condition and are clean and have no cracks or broken insulation. So where appropriate, the requirements, that is the GS38, should be observed, including the use of fused or test leads. Competency of the inspector. So the person doing the inspection also has to be competent. Competent meaning this has to be a skilled person who is also experienced. So the final considerations when carrying out inspection and test is the competence of the inspector. So any person undertaking these duties must be skilled and experienced and have sufficient knowledge of the type of installation. This is is the responsibility of the inspector to, number one, ensure no danger occurs to the people, property, and livestock. Another one is to confirm that test and inspection results comply with the requirements. Another one is to express an opinion as to the condition of the installation and recommend remedial work. Another one is to make immediate recommendations in the event of dangerous situation to the client to isolate the defective parts. Now, the factors to be considered. Now, these are very important things that are normally done or normally takes place during the installation or during inspection. So some of the factors to be considered and isolated are: you have the test instruments. All the test equipment must be regularly checked to make sure that it is in good and safe working order. That is, if you are checking the equipment yourself, if you are checking the equipment yourself, must be regularly checked to make sure that it is in good. Now, if you're checking the equipment yourself, the following points should be noted. That is, if you have any doubt about the instrument, meaning maybe it has short-circuited, or it is not properly installed, or it's not properly checked, or or its accuracy, ask for assistance. That is, or sometimes you might not be sure about using a certain instrument. You have to ask and consult to make sure that the working environment is safe. Another thing that has to be factored in is the voltage indicating devices. These are instruments used for solely to detect voltage fall into two categories. That is, those detectors rely on the illuminated lamp test and the meter scale test. So the meter test lamp are fitted with a 15-watt lamp and should not give rise to danger. The lamp is broken. That is, the guard should also protect it. Now, other detectors also use the two or more independent indicating system. That is, one of which may be audible and limit energy input to the detector by the circuitry used. That is, an example is a two-pole voltage detector, i.e., a detector unit with an integral test probe and an interconnecting lead and a second test probe. So both these detectors are designed and constructed to limit the current and energy that flow into the detector. So this limitation is usually provided by a combination of the circuit design using the concept of protective impedance. And then we go down to protective devices. Now, what happens on the protecting devices? Now, it is not adequate precaution simply to isolate the circuit electrically before commencing work on it. So it is also vital to ensure that once a circuit or an item electrical equipment has been isolated, it cannot inadvertently or be switched back on. So some of the things that are normally done is during the protective devices like the circuit breakers or the fuses are pulled out. You pull out or you tag out, you lock the power supply so that nobody can tamper. So that at any time when you are doing the test and inspection, nobody can come and maybe put on the power without your knowledge. So a good method of providing full electrical and mechanical isolation is to lock off. That is what I've already said. The device, that is for distribution board containing the device. So where with a padlock and with the person working on the isolation equipment, keeping the key in his or her pocket. So a skilled person should be the only one allowed to carry out this on or similar responsible tasks concerning the electrical installation wiring. So the system and equipment. What happens to the system and equipment? Now, prior commencing the work on electrical installation, a full specification is prepared. That is, the specification should be set out on detailed design and provided sufficient information to enable competent persons to construct the installation and to commission it. So the precise details of all equipment installed should be obtained from the manufacturers or suppliers to check that the required standards have been met. So to ensure satisfactory methods of installation have been used and provide the information necessary to confirm the correct operation. So those are among the important safety things that should be carried out before a periodic inspection or test. So a Healthy and Safety Work Act, that is 1974, and the Construction Design Management Regulation, that is the 1994, both state that the requirements of the provision of such information to be included in the operation and maintenance manual prepared for the project. So this should also contain a description of how the installation is to operate and include copies of a distribution board, details identifying the circuit, protective device, and wiring system, and the installation methods. So the source of information, where do we get this information when we want to do the installation? How do we know how to handle a certain thing? So the initial verification is intended to confirm that the installation complies with the designer's requirements. That is, it has been constructed, inspected, and tested in accordance with the BS standard. So the sources of information will be covered in the great details. We are going to cover them in the chapters that follow. Marking and labeling. It's also very important that when we cover the importance of marking and labeling. Now, labeling should show the origin of every installation and also indicate, number one, the differences in voltage, the earthing and boarding connections, and the residual circuit devices. All these are very important when we are doing this installation. Now, contact with the relevant parties. So the testing and inspection procedures needs to be planned. Planned activity is as it will affect others living in, that is working in or passing through the installation. If disruption to others is to be kept to a minimum, they will need to be advised of when and in what areas the activity will be taking place. So they will also need to know the amount of time that the supply may be disrupted. So that is the contact with the relative parties. Now the relative parties are people like now the suppliers, the distributors of power, which are the people like the Kenya Power and Lightning Company. Periodic inspection and testing. So on completion of the area, the candidates now will be able to identify the purpose and the need of periodic inspection and testing. So the purpose of periodic inspection and testing is now initial inspection and testing is necessary on all newly completed installation. So in addition, because all the electrical installation deteriorate due to the number of factors such as damage, wear and tear, corrosion, excessive electrical loading, aging, and environmental influence. So periodic inspection and testing must be carried out at regular intervals. So the purpose of periodic inspection and testing is to confirm the safety of the persons and livestock against the effects of electric shock or burns. So also to ensure protection against the damage to property by fire or here arising from installation defects. So these are some of the reasons why we do this periodic testing and inspection. Another one is confirm that the installation has not been damaged and has not deteriorated to the extent that it may impair safety. So another one is to identify the defects in the installation or non-conformity with the current edition. The intervals, now we have the intervals here. The intervals between the test and determination are the following. That is, the legislation requires that all installation must be maintained in a safe condition and therefore must be periodically inspected and tested. So the table 8 point this below maximum period between the inspection and various types of installation. So listening, licensing authorities also, that is bodies, insurance companies, and other authorities may require public inspection and testing of the electrical installation. So the installation must comply with the standard, that is the BS 7576771. So you can now see the duration of inspection. So it also recommended that inspection and testing should occur when there is a change of use of premises, that is any alteration or addition to the original installation. So any significant change in the electrical loading and installation, that is, and where there is a reason to believe that damage may have been caused by the installation. So you can see now for a domestic installation, that is domestic houses, for domestic houses, we need or it change on occupancy. The inspection should take place after something like 10 years. Highway power supplies now on the roads like 6 years. We have places like churches or schools, places that has large people, 5 years, and then commercial areas, that is it to be changed in occupancy, that is in 5 years. You can see the hospitals, hotels are here. All these are durations that are normally given. The educational premises of 5 years, hospitals 5 years, hotels 5 years, laboratories 5 years, offices 5 years, public houses 5 years, restaurants 5 years, shops. You can see that list. The list is so long. The village halls and community, all those are 5 years. Then we have the agricultural or horticultural caravans. These are now the places that I say now, caravans, cinemas. These are places that normally use the protective devices as the RCDs, the theaters, the caravan parks, the fire alarms, fish farms, the laundries, the marines, the petrol filling stations. Those ones take 1 year. Those ones are the ones that are normally easily damaged, and the swimming pools, they take 1 year. Construction sites are the very urgent. They take at least 3 months before an inspection is done to make sure that things are okay. So in case of the installation that is under constant supervision while in normal use, such as the factory or other industrial premises, periodic inspection and testing may be replaced with the system of continuous monitoring and maintenance of the installation. That is, provided the adequate record such as the maintenance are kept. So when carrying out the design of an electrical installation, and particularly when specifying the type of equipment to be installed, the designer should take into account the likely quality of the maintenance program and the periods between the periodic inspection and the testing certificate. So routine checks. Now, what are the routine checks? So electrical installation should be routinely checked in the intervening time between the periodic inspection and testing. So in domestic premises, it is likely that the occupier will soon notice any damage or breakage to electrical equipment and will take steps to have repairs carried out. So in commercial or industrial installation, a suitable reporting system should be available for use of the installation to report any potential danger from deteriorating or damaged equipment. So the activity and check. So the things that are checked. Now, if there we have activity for defect reports, we check all the reported defects and have been rectified to check if they have been rectified, and also check if the installation is safe. Now, during inspection, now what is checked? When inspecting, what is checked is you look at the breakages, the wear of the deterioration, signs of overheating, missing parts, that is the cover plates or the screws. We check for switch gear, now will are still accessible. We make sure that they are still accessible. We check for enclosures. like the door and the doors are secure. We check for labels that is still adequate and readable, loose fittings. We also check now operation. What do we check in operation? We check if the switch gears are operating reasonably. We check for equipment that is switching off and on. There is the RCDs that is using the test button. Now the recommended period between both routine checks and the formal inspections are given in the table now, and the IEE regulation guidance. I said we will look at the IEE regulation, which is part of the inspection and testing procedure. So the requirements for such inspections are stated in the BS 7671 standard. So in your examinations, at one time, you will even be asked to quote an IEE regulation or from the maybe the BS 761 standards on inspection. You will be able, it is required of you to be able to master these requirements or these codes that are needed during the inspection, and specify that all the inspections should provide careful scrutiny and installation without dismantling, or when with only partial dismantling where absolutely necessary. So it is considered that the unnecessary dismantling of the equipment or disconnection of cables could produce a risk of introducing faults, and where not, there is a fast place. So in summary, inspection should ensure that number one, that the installation is safe. That is one of the things that inspection ensures, that the inspection has not been damaged. Another one is that the installation has not deteriorated so as to impair safety. And another one is any items that no longer comply with the regulations or may cause danger are identified. So in practical terms, the inspector is carrying out a general inspection to ensure that the installation is safe. So however, the inspection is required to record and make recommendation with respect to any items and no longer comply with the current editions. So the statutory documents that is include the following. We have the electricity supply regulations. We have the electricity at work regulations, which are very important. The BS standard 5266 code that is practicable for emergency lighting system. Another one is the BS standard 5839 code, which is a practice for design, installation, and serving of fire alarms. And the local authority conditions. Those are the codes or regulations. Now, the next thing that we are going to do is we are going to look at the process of inspection. Now we have already finished installing. We have the equipment. We know what is needed. We know what to expect. Now we are going to go through the process of inspection. Now, what are these steps? So in new installation, inspection should be carried out progressively as the installation is installed and must be done before it is energized. So normally inspection is done before a house is energized. So for example, if you're doing an inspection or an installation for a house, a new house, or a new build house, or an extension of a house, so you have to inspect before you can power that house. So as far as it is reasonably practicable, so an initial inspection should be carried out to verify that all equipment and material is of the correct type and complies with the applicable British standards or applicable equivalents. So all parts of the fixed installation are correctly selected and erected. Another thing that we also check is no part of the fixed installation is visibly damaged or otherwise defective. Like maybe if it is mechanically damaged, like maybe if something heavy was put on the wire and the insulation, insulation has been removed or peeled off. Another one is that the equipment and materials used are suitable for the installation relative to the environmental conditions. So for the following items must be covered in the inspection. So number one is the connection of conductors. That is, every connection between conductor and equipment and other conductors must provide a durable electrical continuity, meaning there has to be continuity and also adequate mechanical strength. That is, requirements of the enclosure of the accessibility and connection must be considered. Another one is the identification of each conductor. That is, the table of 51 of the BS standard, that is 7671, provides a schedule of the color identification of each cord of cable and its conductor. So it should be checked that each core of the cable is identified and as necessary. So where it is desired, so they are to indicate the phased rotation of an different function for cores of the same color. Another one is the routing of cables. So cable routes shall be selected with regard to the cable suitability for the environment, i.e. the ambient temperature, the heat, the water, that is the foreign bodies, the corrosion, the impact, vibration, the flora, fauna, radiation, building, use of and structure. That is, the cable should be routed out of harm's way and protected against the mechanical damage where necessary. Permitted cable routes are clearly defined in the IEE on-site regulation code. Another one is the carrying out capacity. We have to make sure that the capacity is also catered, that is, where practicable, the cable size should be accessed against the protective device based upon the information provided by the installation designer. A reference should be made as appropriate in the index. So another one is the verification of polarity. It must be checked that no single pole switch or a protective device is installed in any neutral conductor. That is very important. No, it should be checked that no single pole switch or protective device is installed in any neutral conductor. A check must also be made that all protective devices and switches are connected in the live conductor. What do you mean by line conductor? The line conductor is a live pole. Normally, a protective device is like a circuit breaker or a switch. What is the work of a switch? The work of a switch is to break the circuit, and you can only break the circuit on the live conductor. So we have to make sure that the polarity, in checking the polarity, is we are checking and making sure that all the switches and all the protective devices are not installed in the neutral conductor, because the neutral conductor is not the live. So when you install them in the neutral conductor, it will not work. So we have to make sure that all of them are installed in the live, which is also called the line conductor only. That is, unless the switch is double pole. So when we have the double pole, now we can have it done on the neutral and the live. But if it is a single pole, we have to make sure that it is on the live conductor, and that the center contact of the Edison screw lamp holders are connected in the line conductor. So no switches are permitted in the CPP. Another one is the accessories and equipment. Correct connection is to be checked. That is, the BS7671 is a schedule of types of plug and socket outlets available. The rating and the associated British standards, that is, particular attention should be paid to the requirements of the cable coupler. The lamp holder should comply with the BS5042 and be the temperature rating. Another one is the selection and direction of them to minimize the spread of fire. So a fire barrier has to be done. That is, the fire barrier or protection against thermal effects should be provided if necessary to meet the requirements for the BS standard, that is 7671. The regulation requires that each ceiling arrangement be inspected to verify that it conforms with the manufacturer's erection instructions. That is, this may be possible without dismantling the system, and it is essential, therefore, that inspection should be carried out on the appropriate stage of the work, and that is recorded on time to incorporate the inspection and the test of documents. So another one is the protection against direct contact. So we can do protection against direct contact by insulation. We have to make sure that the insulation is okay, and also the earthing. So direct contact is defined by the BS standard 7671 is that the contact of person or livestock with live parts. So the live parts are conductors or conductive parts intended to be energized in normal use, including the neutral conductor by the convention not a combined protective earthing neutral, that is the PEN conductor. That is, the protection is provided using the following methods. The method number one is insulation. We have already talked about insulation. Is in the insulation damage, if the insulation is damaged or has too much been removed, then although protection by insulation is the usual method, there is another method to provide insulation or protection. Now, such things are things like barriers, where the live parts are protected by barriers or enclosures. This should be checked for adequacy and security. So, all have all covers, lids, and plates been securely fitted. And then we also have obstacles to protect. That is, protection by obstacles provide protection only against an internal contact. If this method is used, the area shall be accessible only to skilled persons or to instructed persons under supervision. Obstacles can include a fence around a transformer, substation, and barbed wire fencing on power pylons. So out of reach, there is another one called out of reach. So the placing of out of reach protects against a direct contact, that is increased distance, is necessary where bulky conducting objects are likely to be handled in the vicinity. So the requirements for these methods are given more fully in the appendix for the BS standard that we talked about. Another one is the fault protection. How do we do the fault protection? So fault protections are defined by the BS standard 7671 is the contact of persons or livestock with the exposed conductive parts which have become live under fault condition. So sometimes we have conductive parts that were sealed or concealed, but they have become exposed due to using or under fault condition. So an exposed conductive part is a conductive part or equipment which can be touched but is not live, although it can become live under the fault condition. So example of exposed conductive parts could include metal tracking, metal conduit, and the metal case of the electrical appliance, that is e.g. a classroom overhead projector. Earthing provides a protection against this type of fault. So we'll also need to check that extraneous conductive parts have been correctly bonded with protective conductors. So an extraneous conductive part is the conductive part that is liable to introduce a potential, generally earthed potential, and not form part of an electrical installation. So for example of extraneous conductive parts are the metal sinks, tops, and we this one is also on bonding. And normally when an installation is done, we normally have something called bonding. Where bonding is the equipotential bonding is the connection of all the metallic parts in the house, all the metallic sections in the house, connecting them to the main earthing system. So the methods of fault protection against this standard are: we have the earth equipotential bonding and the automatic disconnection of the supply, which is the most common. The use of class 2 equipment, that is to prevent from fire. The non-conducting parts location, and then the earth-free local equipotential bond. And then we also have the electrical separation. Now the protective device. A protective device have been set correctly for the load. That is, we check also that it is, if reliable, the fuse have been fitted and has a correct size use fuse wire been used. So we also check that if the socket is to be provided for outdoor equipment as the a 30 milliampere rated, that is RCD, been fitted. Also check that checks on documentation. We look at the diagrams. We also keep in mind that anytime we have an installation, we normally do as the wiring diagrams, the schedule, the charts, and the instructions of any other information must be available if inspection and testing is to be carried out in satisfactory manner. Also check the warning notices. Like now, this should be fixed to equipment operating in excess of 250 volts, where this voltage would not normally be expected. Preparing for an inspection. Now, we have already done the process of inspection. What is to be done? Now we want to prepare for an inspection. So where a diagram, a chart, or tables are not available, so a degree of explanatory work may be necessary so that the inspection and testing can be carried out safely and effectively. So notes should be made of any known changes in the environment condition, that is building structure, and alterations which may have affected the suitability of the wiring, of its present load, and methods of installation. So a careful check should be made of the type of equipment on site so that the necessary equipments can be taken where conditions permit to disconnect or short out electronic or other equipment may be damaged. So that is what to be done. So for safety, it is necessary to carry out the visual inspection. Visual inspection is just by looking uh, of the installation before beginning the test or opening the enclosures, that is removing the covers. So when we will go back to school, that is to face-to-face learning, we'll be able to do some of the inspection, these tests in the workshop. So far as it is a reasonable practical, the visual inspection must verify that the safety of uh, persons, livestock, and property is not endangered. So a thorough visual inspection should be made of all electrical equipment that is not concealed and should include the accessible internal condition of a sample of equipment. That is, the external condition should be noted and damage identified. That is, or if the degree of protection has been impaired, that is, the matter should be recorded to the schedule of the report. So this inspection should be carried out without power supply of the installation. So the inspection should include the check on the condition of electrical equipment materials, taking into account any available manufacturer's information with regard to the following. Number one, safety, damage, the age, the wear and tear, the excessive loading, the external influences, the suitability, and corrosion. The assessment and condition should also take into account the knowledge on changes on condition influences and affecting electrical safety, e.g. the extraneous conductive parts, like the plumbing works, the structural changes, and etc. The plumbing works now include the water supply, the sewerage in the house. Most of them you'll get that some of them have the metallic parts that can get connected to electricity in case of a leakage or in case of a fault. So all these, they're called the extraneous parts, the extraneous conductive parts, and they need to be bonded. Bonded is connecting all of them to the main earthing system. So this should include now checking the joints and the connections that are properly secured and that there is no sign of overheating, checking switches for satisfactory electrical and mechanical condition, checking that protective devices are of the correct rating and type, checking of accessibility and damage, checking that conductors have suffered no mechanical damage and have no signs of overheating, checking that the conditions, checking also that the condition of the enclosure remains satisfactory for the type of the protective requirement. Sorry. Okay. Periodic testing. Now, what do we do in the periodic testing? Periodic testing is a supplementary or periodic inspection at the same level of testing as for the new installation is not necessarily required. So when a building is being tested is occupied, isolation of the supply or testing purpose will not cause a problem. But where the building is occupied, then tests should be carried out on cause as little as inconvenience as possible to the user. So where isolation of the supply is necessary, then the disconnections should take place for a short time as possible. That is now the periodic test. Remember that the periodic test is done for the building that has already been occupied and it had already experienced the initial inspection and testing when it was being built. So it may be necessary to complete the test out of a normal working hours in order to keep disruption to minimum. So the following tests, where applicable, should be applied. The continuity of all protective conductors, that is including the potential bonding conductors and continuity of the ring circuit conductors where required. Then we have insulation resistance, polarity, earth electrode resistance, earth fault loop impedance, operation of devices for insulation and switching. We also check the operation of the residual and then we have operation of devices for isolation and switching, operation and residual circuit devices. So detail the test procedures that are needed. We have now, these are the types of tests that we need to carry out. These tests are very important. You will even need to apply them when you will need to apply for a license. Let's say you want to apply for a license at the ERC for a technician license. You need to know these tests because they are among the basic tests that are tested during the licensing. So we have one called the continuity protective conductors, that is the continuity test, and equipotential bonding conductors. It is, in short, it is normally called the continuity test. So where the insulation can be safely isolated from the supply, then the circuit protective conductors and equipotential bonding conductors can be disconnected from the main earthing terminal in order to verify their continuity. So where the insulation cannot be isolated from the supply, the circuit protective conductors and the equipotential bonding conductors may not be disconnected and from the main earthing terminal. So under fault condition, extraneous metalworks, and we already talked about the extraneous parts. The extraneous metalwork could be live. Under these circumstances, a combination of inspection, continuity testing, and earth loop impedance test should be established. Should establish the integrity of the circuit protective conductors. So when testing the effectiveness of the main bonding, the conductors or supplementary bonds and resistance value between any service pipe or extraneous metalwork and the main earthing terminal should not exceed the 0.05 ohms. That is a requirement. And then we have another test called the insulation resistance test. So number one, we said the continuity test. Number two is the insulation resistance test. So in insulation resistance test can only be carried out where it is possible to safely isolate the supply. So all electronic equipment susceptible to damage should be disconnected, or alternatively, the insulation resistance test should be made between line and neutral conductors connected together and the earth. So where practicable, the test should be carried out on the whole of the insulation with all switches closed and all fuses linked in place. So where this is not possible, the insulation may be subdivided by testing each separate distribution board one at a time. So the BS7671 table 61 states a minimum acceptable resistance value of 1 mega ohm. However, it is measured value less than 2 mega ohm, then further investigation is required. So that is the insulation resistance. We have to make sure that the insulation resistance test that the safety is safety of isolation. The supply is make sure that all electronic equipment are susceptible to damage should be disconnected. So during insulation resistance tests, we make sure that all the equipment are disconnected. Polarity test. So polarity test should be carried out to check that the polarity is correct at the intake position and the consumer unit are or distribution board, single pole switches or control devices are connected in line with the conductor only. So the socket outlets and other accessories are connected correctly also, and the center contact, that is the bayonet, the Edison screw type holder, have their outlet or screwed contact connected in the neutral. That is the polarity. You remember that when we talked about the polarity, that is we make sure that the correct intake of position of the consumer unit and the distribution board and the single pole switches are also, and the control devices are on the line conductor. That is the polarity. In polarity, in short, what we do is to make sure that the live goes to the live and the neutral goes to the neutral. Another one is the earth fault loop impedance. The earth fault loop impedance test should be carried out at, that is, the origin of each insulation and at each distribution board. So all the circuit outlets at the farthest point of each radial circuit. That is, results obtained should be compared with the values documented during the previous test. So, and where an increase in values has occurred, this must be investigated. Now, the operation of the main switch and isolators. All main switches and isolators should be inspected for correct operation and clear labeling. So, and to check that access to them has to be obstructed. So where the operation of the contacts of such devices is not visible, it may be necessary to connect a lamp test, that is between each line and neutral of the load side of the device, to ensure that all the supply conductors have been broken. Another one is operation of the residual devices. That is, the RCD should be tested for correct operation by the use of the RCD tester to ensure that any trip out in any time required by the standards, as well as the use of the integral test button. So the check should also be made that the tripping current of the protection of an socket outlet should be used for equipment outdoors and should not exceed 30 milliampere. Operation of the circuit breakers. All circuit breakers should be inspected for visible signs of damage or damage caused by overheating, where isolation of the supply to individual sub-circuits will not cause inconvenience. Periodic test and inspection report. Now, after doing the test, we need a report. So the BS 7671 standards requires that the results of any periodic inspection and test should be recorded on the periodic inspection and test report of any type illustrated in the figure. We are going to see the figure now of the installation were covered. Now, what is covered there is a description of the extent of inspection and the test and what parts of the installation that were covered. Another one is any limitation, that is, e.g., the portable appliance not covered. Another one is the details of the any damage, deterioration, or dangerous conductor which were found. Another one is any compliance with the standard, and then the schedule of the result. And remember that you are asked to carry out the periodic inspection at small workshops. So it also goes well until you come up with check the office that is attached to the factory, where you notice that about 20 staff are working on the computers. So no installation drawings exist on the office. So as in turn out, the factory was built as an extension of the office many years ago. So what can you do? Now, can you identify the problems you will encounter in the job, or would you deal with how would you deal with the situation? That is, those are the brainstorming questions that need to be asked. So if any items are found which may cause immediate danger, so this should be rectified immediately. If this is not possible, then you must report to the responsible person without delay. When inspecting older installations, now which may have been installed in accordance with the previous edition, that is the IEE wiring regulation provided in all the items which do not conform to the present edition, then a reported an installation may be still be acceptable. So the provided that no risk or shock, fire, or burns exists. Summary of the test. We have now for the continuity test, continuity protect. We said the types of tests that are carried out. Now the continuity test, which is the test to be carried out between all the main bondings and all the supplementary bondings. That is in the bonding for the equipotential bonding, and that is to make sure that the earthing is properly installed. That is not that all electrical insulation cannot be isolated, so the protective conductors, including bonding conductors, must be disconnected. Another one is the installation resistance. That is, if this test is to be carried out, then the test one would, the whole installation will, with all protective devices in place and switches enclosed. Where electronic devices are present, the test should be carried out between the phase and the neutral conductors. Another one is the polarity test. The test to be carried out, that is the origin of installation. All socket outlets are to be carried out. Another one is the polarity test. We said that the polarity test is carried out on the original installation, also on all sockets, on 10 per centimeter of control devices, that including the switches, the 10 per centimeter of the contact lamp holders. Note that if incorrect polarity is found, then a full test should be made on the part of insulation and testing on the remainder of the increased to 20%. So if further faults are found, now the complete insulation must be tested. The earth fault loop impedance. This is a test carried out at the origin of the installation, also at each distribution board, at each socket outlet, and the extremity of every residual circuit. And then we have additional protection, that is the test of the RCDs. We also have the phase sequence test, that is the test that the phase sequence is correct. We have the functional test, that is activities to be carried out all in installation. We make sure that the insulation, the isolation, and the switching devices are to be operated. All labels are checked. Interlocking mechanisms are also verified. All the RCDs are to be checked. Both the test instruments and the test buttons are checked also. Also, we check all manual operated circuit breakers are to be operated. And also we check the voltage drops that may be verified to measure the circuit impedance. And then as well, you can see now the standard is here and it is quoted. Relevant sources of information, that is the statutory and non-statutory regulations. These are the IEE standards. Now, the IEE 7671, you will use this standard to document against which of the professional judgment needed that is to be made, alongside with the regulation and accompanying documents. You will also need the IEE on-site guide, that is IEE guidance notes inspection testing. These contain the tables and charts, and then you have information like now the earthing, the normal earthing, the normal voltage, and all those are the things that are needed when you are doing the checking, the inspection, and testing. So the following should be provided as part of the design information, which should be checked by the persons carrying out the inspection. That is, they may have the sign of electrical installation certificate and information. That is the type and composition of the circuit. We have the method used to meet the requirements. We have the information to be able to identify each protective device. We also have a circuit or equipment. that may be vulnerable to the test. Now, up to that point, I want us to stop there for any questions so that we will go to the discussion part. So after that, we will be able to meet next week and proceed with the test and inspection. Then we will cover also the IEE regulation. The IEE regulation. So I want you to unmute your mic so that I can hear at least a question or anything. Unmute your mic. Yes, Francis. Yes. Can I hear maybe a comment or a question up to where we have reached?
I have no question.
So, did you understand the inspection, how the procedure is taken, what is needed?
Yeah.
Okay, so I want us to go to the discussion and at least say something. So next week, I don't know why your classmates are not